Okay, group 4. A physics student uses tracker software to determine the motion of a horizontally launched cannonball. So remember, we always want to look at that. Horizontally launched tells us a couple of things. It tells us that the initial velocity equals the horizontal velocity, and that Vy is 0 meters per second, or Viy is 0 meters per second. Okay? How far would any projectile, it really doesn't even have to say horizontally launched, how far will any projectile fall in 1 second? So I'm trying to find a distance, right? I want to know the distance that this will fall in 1 second. So I'm actually going to grab this equation right here, which says that the change in the y direction equals the initial velocity in the y direction multiplied by time plus 1/2 gt squared, and g is a. Okay, so if I start to fill in some information here, like we said, if it's a horizontally launched projectile, the initial velocity is 0. So this would become delta y equals 0 multiplied by the time, which is 1, plus 1/2 for g, we're going to use 10. Time, and then t, we're still using time, right? Our time is 1 second times 1 squared. Okay, so 0 times 1 is 0, so that just goes away. So delta y equals 1/2 times 10 is 5, 1 squared is 1, and so in 1 second, any object that is in free fall will fall 5 meters down. Okay. So that's the first step, is to figure out where will something fall after 1 second. It'll be 5 meters below where it started. So at the point in our projectile now, right, so any projectile whatsoever is always going to fall 5 meters in 1 second. So when the projectile, at least in the first second, when the projectile has fallen that far down, we want to see for our particular projectile how far had it moved to the side. So I'm going to come over to my table, or my graph, and let me look at it. So it started at 40. And it fell down to 35. So that's when it has fallen by 5. And now I'm just going to follow that across until I reach where it would be when it's at 35, this way. Right, where is it horizontally? Down here is my horizontal distance, so I see it's 510. It's at 12 meters, okay? So after 1 second, so my delta x is 12 meters in 1 second. And so this says, use this information to calculate the ball's initial horizontal velocity. Okay, well, to find velocity, we can come back to our trusty table, right? Or our trusty formula sheet. Velocity is distance over time. So here's distance and here's time. So I'm going to say velocity in the x direction equals the distance in the x direction divided by time, or Vx equals 12 over 1. Vx equals 12 meters per second. Okay? If the initial velocity was faster, would it take more or less time to fall? We have to kind of step back for a second and think about the problem. So in this case, the initial velocity is equal to the horizontal velocity. When we think about the time something has to fall, that has much more to do with how high it is off the ground, like the distance off the ground, than it does with how fast it's moving to the side. And so if the initial velocity was faster, would it take more or less time to fall? Changing the initial velocity, or the Vx in this case, would not impact the time to fall. The height would have to be changed.